You go, ooh. So let's practice that. If it changes color, what do you do? Okay, if it bursts into flames, what do you do? And if it goes boom, what do you do? You go, holy moly. So one more time. Changes color. Bursts into flame. Boom!
Holy moly! Woo! Alright, so we have a little birthday celebration, and Valentine's Day is coming up, and what is more romantic than a blowtorch? So I'm going to give you guys a nifty little show here. Get this all fired up. Make some mood lighting here.
Now we thought it would be very worthwhile to start our show with this because it's been so cold for so long. This sometimes is called the glacier experiment, the burning glacier. Light up my light. Hello.
We're going to continue our little party over here.
Party?
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 Yep.
Hey, I like going to parties. I like bringing a drink with me. I like sweet drinks, kind of like soda. You know what? I think I do some cherry soda. So I'm going to take my water, I'm going to pour it into my little doohickey here, mix it back over, you know, get my water just right, and then make a little cherry soda.
So we've got enough cherry for everyone, but you know, New Year's just passed. Everyone probably has their New Year's resolution. Maybe you want to cut down on your sugar. So I think it should be a little bit more healthy. Maybe we should go back to water.
Really? Water it is. I take my cherry. Let's make a little bit of water.
There you go.
Wait a minute. What's the correct terminology here?
Well, I mean, it is a party, so water's kind of boring. Maybe we could do something that's not water, but it's healthy?
Water, healthy, young people. They need strong bones.
They do. Strong. Yeah.
Milk it is.
Woo. Healthy, nutritious, delicious milk. Bring milk to a party, right?
It is every time.
Though that's not necessarily party milk. What would you consider party milk?
Chocolate milk.
Yeah.
Chocolate milk it is. Chocolate milk, anyone? Thank you very much. Good afternoon, everyone. No. Good afternoon, everyone. That's much better. How many of you have ever heard of a dirigible? How about a blimp? Ah, yeah, same thing, different generation. I get it. So a dirigible or a blimp used to be filled with something called hydrogen. However, there was one small problem with this stuff we call hydrogen. It doesn't necessarily react very well to flame.
particularly for you people in the front row who do have insurance, right? Yeah. No, you're okay. You're good. You're good. You're good. You're good. You're good.
You really think this is a good idea?
Oh my god.
Ladies and gentlemen, sorry, a little chemistry trickery, but two different things, helium and hydrogen, both less dense than air. However, one of them reacts very differently to flame than the other. Thank you very much.
You guys seem to like the explosion. You didn't like the explosion? Did you like the explosion? You'll have to excuse me, I had to water the flower before I do my little demonstration.
I thought you wanted to how do the flowers die?
This is for later. Alright folks, the first balloon that you saw contained hydrogen gas, and what you basically witnessed was a chemical property of hydrogen gas. It's flammable, and that basically means it reacts with oxygen to produce a flame, which you saw. So I'd like to do a little extension of that. This demonstration is called dynamite soap, and it's got two parts. Basically what we have here is hydrogen gas, but it's trapped in a bottle with some soapy water. So by shaking, we are trapping the hydrogen gas in the bubbles. So now the bubbles have hydrogen. So I'm going to pour this out into a pie tin, and it's mostly the bubbles I'm interested in. So we'll squeeze all those out. Those are hydrogen bubbles. And if I place a flame by it, someday, they don't make matches like they used to. If I place a flame by it, it will ignite. Now, that wasn't very exciting. You did see combustion, but combustion is a reaction of hydrogen with the oxygen in the air. And the air only came in contact with the surface of the bubbles. So that's the only place you really saw the reaction. It was nice, it happened. But in this bottle over here, we pre-mixed the oxygen in the bottle. So what's the formula for water? Okay, so we have 2 parts hydrogen and 1 part oxygen, and it's already mixed in. So the reaction will not just take place at the surface. All of the hydrogen will react. So, we must mix. Make our dynamite soap. That's required, by the way. Again, we're interested in the bubbles only. Really don't care about the water, although we are making water chemically. Ready? Dynamite zone. What you witness is how increasing the concentration of a reactant affects the rate of